online survey video tutorial on hydrology and irrigation engineering. So today we are discussing module 3, that is runoff. Under that, the topic which we are going to cover in this video is runoff and the factors affecting runoff. So let us see the definition of runoff. Okay, so runoff is a portion of rainfall which falls onto the earth's surface and flows towards the ocean, and chiefly in the form of rivers, lakes, and streams. So this is runoff is also one of the loss of water, like as we have discussed. So we have various losses of water like infiltration, okay, and after that evaporation, evapotranspiration. So all those things we have discussed. So another form of loss of precipitation is the runoff. So runoff can be defined as it is that portion of rainfall, so which falls onto the ground surface and flows towards the ocean. So that is through the streams, rivers, lakes. So so this runoff consists of a precipitation, so which neither evaporates, so not transfers, or which is not penetrate into the ground surface. So that portion of rainfall is said to be a runoff. So in another terms, we can define runoff as a total rainfall minus the evaporation and percolation, or it is also defined as that part of rainfall which reaches the streams, so and forms its basin catchment area, so within a given time. So that portion of part of a rainfall is called a runoff. You can see the relation: runoff is equal to rainfall minus evaporation minus the percolation losses, and it is usually expressed in terms of volume per time per unit time, that is nothing but a meter cube per second or a cubic. So or it is also expressed as depth in terms of mm per day or mm per month or mm per year. So the next topic, coming to the factors which affects the runoff. So we have various factors which affect the runoff. So the main factors are rainfall pattern, character of catchment surface, topography, shape and size of the catchment, vegetal cover, geology, and weather condition. So these are the various factors which are affecting the runoff. Let us see one by one how the rainfall and topography is affecting the runoff value. So the first factor which affects the runoff is rainfall pattern. Okay, so here if the rain, as we already know, the main source of all the losses is the rainfall. Okay, so if the rainfall is heavy, then obviously the runoff will be more. And also, if the rainfall is just a showery type, like if the intensity of rainfall is very low, then the runoff will also be very low. And in case of showery type of precipitation, so there may not be runoff also, because whatever the part of precipitation which falls onto the ground surface, so it will be lost as an evaporation, infiltration, and while falling itself, due to the interception or the evaporation while falling, that is nothing but the throw fall. So in that form, the rainfall gets lost, and there may not be runoff value. So that is how the rainfall pattern affecting the runoff value. The second factor is the character of catchment surface. Okay, so if the surface, like if it is a rock surface, then the absorption capacity will be low. So in that case, obviously the runoff will be more, because the rock will be not a permeable strata. So rocks are nothing but a impermeable strata, so the absorption will be nil in that rock surface. So at that particular case, you can see the more runoff. And also, so if the surface is a clayey compact, okay, so if the surface is clayey type, then what happens, the runoff will be more. And if it is a sandy surface, so if the surface is sandy, then absorption losses will be more and runoff will be very less. So that is how the catchment surface affecting the runoff value. And the third factor is the topography. Okay, so how the topography is affecting the runoff value. See, if the surface slope is very steep, okay, the runoff will be more, because so if the surface is very steep, then the rainfall which pass fall onto the ground surface can easily flow. So it will flow rapidly. So then the runoff will be more. So if it has, the surface will be, the slope is a mild slope, then in that particular case the runoff will be less. Okay, and so if there are a local depressions, okay, so then water will be held up in the depression, forming a lake and ponds and etc. Okay, so if there is any depression, then what happens, whatever that runoff water which flows so very fastly, so due to the steep slope, that will be form as a lakes pond, so in that depression which is present in the topography. And the fourth factor is the shape and size of the catchment. So how the shape and size of the catchment is affecting. So if the catchment area is large, then obviously the runoff will also be large, means the runoff will be more. Okay, if the catchment area is a fan shape, like it will be like a fan shape, then the runoff at the outlet will be more. Okay, so for a fan shaped catchment area, the runoff will be more. So and also that will as the runoff will be more, that will so contribute to the streams more. And also if the catchment is a fern shape, then the runoff will be less. So those are the two shapes of a catchment which affects the runoff value. So if the catchment is fan shape, then the runoff will be more. If the catchment is fern shape, then the runoff will be less. And the fifth factor which is affecting the runoff is the vegetal cover. Okay, so if the some sort of vegetal cover, so if there is a vegetal cover, a dense forest like that, so then what happens, the evaporation losses so will be less, because if the ground surface is covered with the vegetal cover, what happens, then the sunlight cannot pass pass through that vegetal cover and falls onto the ground surface. So if the sun rays are less onto the ground surface, then the evaporation will be less, so where that will reach to the more ground runoff of value. Okay, so if there is a dense vegetal cover, then the runoff value will be more. So the next factor is geology of the area. So how the geology of the area affecting the runoff value. So if there is fissures, cracks, fault zone, okay, so if those geological factors features are there in the catchment, then the rainwater will find its way out through these openings, because so these are like cracks are like openings. Okay, so what happens, so if these type of geological features are present on the catchment area, then water will find a way through this crack, so through these openings, and it will come out through that. Okay, so and the water is lost, maybe find its way to some other catchment or to the groundwater or in the sea. So what happens if due to this, because of this cracks, faults, so the water will percolate inside the catchment and reaches the groundwater, and ultimately it may reach to the sea, so where that will reduce the runoff value. So that is how the geology is affecting the runoff. The last factor is a weather condition. So how the weather condition affects the runoff value. Okay, so if the temperature is more, then the runoff will be less. If the temperature is is less, then obviously runoff will be more, because so if the temperature is more, evaporation losses will be more. Okay, so if the losses are more, the runoff will be reduced. So if temperature is low, then losses will be low, then the runoff will be higher. And also, as I told, temperature is more, then so because of the dry condition of the soil, then what happens, so whatever the rainwater which is falls onto the ground surface will be absorbed by the soil particle, and that will reduce the runoff value. Okay, so in that particular case, evaporation rate will be more, so that the runoff value will be very less. Thank you all. So let us see the next topic in the next class.